Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Yeah, already we are discussing about the introduction of CSIR and GATE examination papers in physics. Physics, total 9 papers we have. First, mathematical methods of physics, we uploaded in YouTube. Classical mechanics, electromagnetic theory, quantum mechanics, thermodynamics and statistical physics, electronics and experimental methods. Lastly, condensed matter physics, atomic and molecular physics. The last paper is nuclear and particle physics. This is very, very important. Nowadays, nuclear power is more predominant roles takes place because in the universe, coal is not available. So much of coal we are taking from out. So this coal is not available nowadays. That's why we are going for the whichever the more predominant and renewable source. That source is the nuclear source. We have to create the so much of energy by using the nuclear fusion and nuclear fission reactions, right? Now recently in Indian government also in Tamil Nadu, Kudankulam, they established one nuclear plant by the help of the Russian government. Like that, so many nuclear plants we installed in India. One day we have to give one demo, one video I will keep and I will upload in YouTube also. How many nuclear reactors are there in India, what they are producing, how much power is producing in Indian government through the nuclear system. Whatever it may be, this is the basic idea, nuclear and particle physics, right? Nuclear and particle physics in CSIR and GATE also we have the syllabus. In this video, we are discussing about the syllabus of CSIR and GATE, nuclear and particle physics concerning, and exam pattern, how it will be there in CSIR and GATE exam pattern, nuclear and particle physics both, and some important whatever the previously they are asking the questions, those questions we have to discuss in this video, right? That is nuclear and particle physics. Now we will see. Already I told in CSIR 2 sections are there, but 2 sections only for 6 papers. Only for 6 papers, 2 sections. First you have to see the first paper is suppose you have to take one more slide I will take and I have to teach to you. Once you have to see in CSIR 2 sections are there. One is core and advanced part is there. One core. Next is advanced part is there. Part A. This is core is part A and advanced part is also is there. That is part B. Which one it is? Advanced part. Advanced part, that is the part B. Now you have to see in core part A how many papers are there. One is mathematical methods of physics. Core and advanced is there, mathematical methods of physics, right? The second one is classical mechanics. In classical mechanics also core and advanced syllabus is there. The third one, if you have to take a electromagnetic theory, in electromagnetic theory also core and advanced is there. Core and advanced is there. The fourth one is quantum mechanics. Quantum mechanics also it consists of the core and advanced. The fifth one is thermodynamics and statistical physics. Thermodynamics and statistical physics. Here also core and advanced is there. Thermodynamics and statistical physics. Core and advanced is there. Now the sixth one is which one it is? Sixth one, electronics and experimental techniques. Electronics and experimental techniques or experimental methods. Electronics and experimental techniques or experimental methods. Here also electronics and experimental methods or experimental techniques, core and advanced is there. These 6 papers, core and advanced is there. Please remember, total 6 papers. From these 6 papers, you will get out of 170, you will get 140 marks. If you clearly prepare these 6 papers, out of 200, you will get the 140 marks. Rest of the 6, suppose you have to see, the 7th paper is atomic molecular physics, the 8th paper is condensed matter physics, the 9th paper is nuclear and particle physics. 9th paper is nuclear and particle physics. From this paper, so in atomic and molecular physics, 5 marks questions, 3 it will come, 15 marks. Here also condensed matter physics, 5 marks question, 3 will come, here also 15. In nuclear and particle physics, 5 marks question, here also 15. Total how many? 45 marks you have to get it. Total 45 marks. 45, 170, no, sorry, 170 plus 45. How much you have to take? You subtract from 170, 45, 5. So, you have to take 2, 125. Sorry, 125 you will get from these papers. 125 marks you have to get from these papers. Clear? 125 marks you will get from 45 marks weightage is there, this one. But 140 also you have to do some extra questions also you have to do, because a choice is there, that choice also you have to use for this. This is the thing. Already we discussed atomic and molecular physics, condensed matter physics. This one is the last paper. That paper is nuclear and particle physics. What is the nuclear and particle physics? Nuclear particle physics, there is no core syllabus. There is no core syllabus. Only advanced syllabus is there in CSIR. Please remember, only advanced syllabus. How many questions will come? Only 3 questions will come. Only 3 questions will come. 3 5 ja 15 marks you will get in CSIR examination. What is the syllabus? Once you have to see. Nuclear and particle physics. Basic nuclear properties. In basic nuclear properties, first you have to take about a basic nuclear properties. From basic nuclear properties, we have to take the size, shape, charge distribution, spin and parity, binding energy, semi-empirical mass formula, liquid drop model, nature of the nuclear forces, form of nucleon-nucleon potentials, charge independence and charge symmetry of nuclear forces, deuteron problem, evidence of cell structure, single particle model and its validity, limitations, rotational spectra, elementary ideas of alpha decay, beta decay, gamma decays and their selection rules, nuclear fission, nuclear fusion, nuclear reactions, reaction mechanisms, compound nuclei, direct reactions. This is the nuclear part, entire up to direct reactions there is a nuclear part. Which part it is? Nuclear part. Now you have to see, this one is a particle physics, classification of fundamental forces, elementary particles and their quantum numbers, charge, spin, parity, isospin, strangeness, Gell-Nishijima formula, quark model, baryons and mesons, charm, time invariation and then application of the symmetry arguments to the particle reactions, parity, non-conservative in weak interaction, relativistic kinematics. This is the syllabus, right? This syllabus is only advanced part. There is no core in nuclear and particle physics. How the question paper pattern once you have to see. Total questions you will get a question paper pattern part A. Part A is general aptitude questions. You will get the 20 questions. Out of 20 questions you have to attempt 15 questions. Each and every question carry 2 marks. Each and every wrong question you may lose 0.5 marks. General aptitude once you have to see. General aptitude with emphasis on logical reasoning, graphical analysis, analytical and numerical ability, quantitative comparison, series formation, puzzles are there. This is the part A, that is completely general aptitude. From part B, there is no nuclear and particle physics questions. There is no nuclear and particle physics questions, but in part C, out of 30 questions, you get 3 questions from nuclear and particle physics. 3 also you can attempt. Each and every question 5 marks is there. Each and every wrong question you may lose 1.25 marks. Clear? Total 3 nuclear and particle physics, 1 particle physics, 2 nuclear physics, otherwise 2 particle physics, 1 nuclear physics. Sometimes they are asking like that, sometimes they are asking like this also, they are asking. This is very important type. Clear? Now we will see the GATE section. This is the last paper. In GATE also last paper, in CSIR also this one is a last paper only. Now you have to see nuclear and particle physics. How we have to approach the nuclear and particle physics. What is the syllabus? Nuclear radius, nuclear charge distribution, nuclear binding energy, electric and magnetic moments, semi-empirical mass formula, nuclear models, liquid drop model, nuclear shell model, right? Nuclear forces, 2 nucleon problems, alpha decay, beta decay, electromagnetic transitions in a nuclei, Rutherford scattering, nuclear reactions, conservation laws, nuclear fission and fusion, particle accelerators and detectors. Particle accelerator and detector there is not covered, but here covered. Elementary particles, photons, baryons, mesons, leptons, quark model, conservation laws, isospin, symmetry, charge conjugation, parity, time reversal invariance. This is a particle physics syllabus, right? This one is the GATE syllabus. From the GATE, once you have to see exam pattern of the GATE. What is the exam pattern of the GATE? General aptitude 15 marks you will get from the general aptitude, right? From question number 1 to 5, each and every question 1 mark. Question number 6 to 10, each and every question you will get the 2 marks. Total 15 marks for general aptitude. In physics, 85 marks you will get, right? Question number 11 to 35, you will get 1 mark. Question number 36 to 65, you will get the 2 marks. Each and every question you will get the 2 marks, 36 to 65. Total 55 questions you will get from physics. Total 55 questions you will get. Maybe you can get it from nuclear physics, 5 or 6 questions you will get. Nuclear and particle physics. Clear? There multiple choice questions are there. Multiple select questions are there. Numerical answer type questions are there. 3 varieties of questions are there. For numerical answer type question, there is no negative marking. Please remember. So many times I told. Now, which type of books we have to follow? These are very important. So many fundamental books are there for nuclear physics. These books are very nice books. You can purchase any one book. Nuclear Physics, Irvin Kaplan. This book is very nice. Introductory to Nuclear Physics, Kenneth S. Crane. This book also very nice. Introduction of Elementary Particles, David J. Griffith. This book also nice. Particle Physics, C.L. Arora. Nuclei and Particles, and Introduction to the Nuclear and Subnuclear Physics, Emilio Segri. For particle physics, this book is very nice. Nuclear and Particle Physics, Niels Wallet. An Introduction to the Nuclear Physics, W.N. Contingham and D.A. Greenwood. This book also very nice book. These all 7 books are very nice book. Any one book also you have to take. Otherwise, DC Thayil book you are preparing in MSc. That book also nice only. But that book I am not quoting. All the foreign author books I quoted because these books are standard books. Once you have to read these books, you will get the more knowledge. Sometimes you won't get understanding, but if you have to get the understand this sense of this book, you will get the more idea in that one. Now we will see, we will inform you the CSIR GATE batch we have to start from 7th January 2024 onwards we are planning, but we are shifting this one to 18th January 2024 onwards, live plus recorded classes. Already recorded classes are available in that. Live come recorded classes will happen through app, not YouTube, through app only. Please remember, morning 6 a.m. to 8 a.m. every day, Monday to Saturday, there is a class is there. Sunday, complete Sunday is rest. Every Monday you have to write a exam. Every Monday you have to write the exam, because exam also you have to write in app only. Exam also you have to write in app only. Clear? This one you have to follow. If you want to really interest my teaching, if you really want CSIR or GATE, crack the CSIR and GATE, otherwise you have to learn the PG level subject, you take this course. This is very niceful to you. This course will available from Google Play Store. You have to download the Quantum Online Academy app. From that app, you have to purchase the app. Then you go to listen the classes. Now I segregated the syllabus. How I am segregating, once you have to see. I segregated the syllabus in 10 parts. Each and every paper I am segregating 10 parts. No? Same way I segregated 10 parts. How I am segregating, once you have to see. Basic nuclear properties. You may get 5 marks CSR question or 1 mark GATE question you may get from that. Next, nuclear models. Here a liquid drop model is there. Liquid drop model and single particle model. 2 models you have. From these 2 models you may get any one model, 1 question. 5 marks question or 2 marks question. 5 marks question CSIR, 2 marks in GATE. Nature of nuclear forces. Nuclear force nature is very important. 5 marks in CSIR, 1 mark in GATE. Radioactivity, alpha decay, beta decay, gamma decays are there. So these decays and decay loss also is there. From those loss you will get 5 marks in CSIR, 2 marks in GATE. Nuclear reactions, direct reactions, compound reactions, such type of reactions are there, no? So from that also you have to listen this one. Whether it may be question will come in CSIR, whether it may be easy question or tough question, that question belongs to 5 marks question only. Please remember. Now, electromagnetic transitions in nuclei, that also one area. This area is very important. Here gamma Teller transition, Fermi transition, those transitions we have to learn. Particle accelerator and detectors. Particle accelerator, cyclotron, cyclotron and detectors, GM counter, scintillation counter, proportionality counter, those things we have to learn from here. Now, fundamental forces. 4 type of forces are there: strong force, weak force, electromagnetic force, gravitational force. Those forces we have to learn from here. From forces also you will get 1 question. Elementary particles and their quantum number. Leptonic quantum number, baryonic quantum number, mesonic quantum number. These quantum numbers are there. Charge quantum number, spin quantum number. Oh, those quantum numbers also they will ask. Next, quark model. So quark model also very important. 10 parts I segregated. Like this also you have to prepare. You will get easily understand the syllabus and easily understand the subject. You won't feel burden, right? That is the very important one. Now we will see one question. One question we will see what is the area is there. That area we will see. Now you have to take. The radius of the copper 29 to 64 nucleus is measured. The radius of the copper they are giving. How much they are giving? 4.8 into 10 to the power of minus 13 centimeters they are giving. The radius of the copper, which one it is? Copper 2964, right? Now the copper is given. Then the radius of the magnesium, the radius of magnesium is equal to how much they are asking. The radius of the magnesium atomic number is 12, mass number is 27. Clear? Now, how we have to calculate? Once we have to see how we have to calculate this one. We have to see here how we have to calculate, Nana. First, there is a procedure. One formula is there. R is equal to, this is the size of the radius. R is equal to R naught into a to the power of 1 by 3. R naught is the constant value, that is 1.2 to 1.4 Fermi is there. Therefore, R is proportional to a to the power of 1 by 3. Now I am converting to here. How I am converting this one? You have to see. R of copper is divided by R of magnesium is equal to a to the power of copper whole to the power of 1 by 3 is divided by a of magnesium whole to the power of 1 by 3. Now you substitute R copper is divided by R magnesium is equal to a copper is equal to how much? 64 whole to the power of 1 by 3 is divided by a magnesium is equal to how much? 27 whole to the power of 1 by 3. Now 64 is equal to 4 cube, 4 ja 16, 16 4 ja 64, 4 cube is there. So now you have to write 3 cube get cancelled. How much, what is we are finding? R magnesium we need to find out. R magnesium is equal to 3 by 4 into, I am cross multiplying, 3 by 4 into R copper. R copper is equal to, how much you have to substitute? 3 by 4 into 4.8 into 10 to the power of minus 13 centimeters. 4 1 ja, 4 1 ja, 4 2 ja. So 3 1 ja, 3.6 into 10 to the power of minus 13 centimeters. What is your answer? Your answer is 3.6 into 10 to the power of minus 13 centimeters. Option C is correct. How simple it is. 5 marks you easily you have to get it. Very clear. If you know this formula, how we have to apply the formula, then easily you will get it. Very simple. Simple and simple. Simplest one it is. Now you have to see. According to the shell model, the total angular momentum of the parity of the ground state of lithium 37. Total angular momentum means J, and parity we want to calculate. Which one? Lithium 37. How we have to calculate? This is a single particle model or shell model question. This question is, which question, Nana? This question belongs to shell model question. How we have to fill the electrons? To fill the electrons, there is a one shortcut is there. That shortcuts, whenever you have to join in our institute, I will teach that shortcut. First, you concentrate how I am doing this problem. Once you have to see first. Lithium 37 they are giving. Lithium 37. First you have to write the number of photons. The number of photons is equal to the number of protons. The number of protons is equal to 3. 3 is a odd number. That's why single electron should exist. Single electron should exist. We need to write the configuration of that. Next, the number of neutrons. The number of neutrons is equal to A minus Z is equal to 7 minus 3 is equal to 4. 4 is a even number. It won't participate in the single electron. We have to write the configuration. Proton configuration. We have to write proton configuration. Proton configuration. What is the proton configuration? How we have to write once you have to see. How many electrons are there? How many protons are there? 3 protons are there. We have to write the proton configuration. How we have to fill the electrons in the similar way. According to the shell model, we have to fill the nucleons. What are the nucleons? Protons and neutrons. Whether which one is odd, that one you have to fill it. Right? If both is odd, also you have to fill. But one is even, one is odd. We are following for odd only. First electron can fill 1s 1 by 2. How many protons can fill? 2 protons can fill. Next, so 1p, you have to take here 1p 3 by 2. Next level is 1p 3 by 2. First level is 1s 1 by 2. 2 electrons we are filling. Next, third electron can fill 1p 3 by 2. This p is a p orbital. P orbital means what is L is equal to 1. If it is p orbital, if you have to take a p orbital, L is equal to 1. J is equal to how much? J is equal to 3 by 2. Parity is equal to minus 1 to the power of L. Minus 1 to the power of 1 is equal to minus. Therefore, what they are asking? Parity and total angular momentum. Total angular momentum is equal to 3 by 2. Parity is equal to minus 1 to the power of 1 is equal to negative. Which one we are getting? Negative. Therefore, 3 by 2 negative is the answer. Once you have to check it. Which one we are getting? 3 by 2 with negative parity. Option A is correct. 3 by 2 with negative parity is correct. 3 by 2 with positive parity wrong. 1 by 2 with positive parity wrong. 7 by 2 with negative parity wrong. Very simple. Only shell numbers are there. What are the shell numbers? Once you have to take a shell numbers, these numbers we call it as a magic number. Magic numbers. Cell numbers we also call it as a magic numbers. 2, 8, 20, 28, 50, 20, 28, 50, 82 and 126 like these numbers are there. These numbers are shell numbers. Shell numbers means completely filled. Protons are nucleon. Protons are neutrons. Completely filled shells we call it as a magic number or shell number. These numbers, protons are nucleons. That nuclei is more stable nuclei. Whenever we have to learn, that time we have to teach this one. That is the second one. Now third one you have to see. Deuteron has only one bound state. Deuteron, this is the isotope of the hydrogen. Deuteron has only one bound state with spin and parity is equal to 1 plus. Spin and parity is equal to 1 plus. Isospin is equal to 0. Isospin is equal to 0. Electric quadrupole moment is equal to 0.286 EFM square. Electric quadrupole moment. These data suggests that the nuclear forces once you have to see some properties are there. Nuclear forces properties. What is that? Nuclear forces properties. What are the nuclear forces property? It is a spin dependent, charge independent. Spin dependent. The second one you have to remember, charge independent. Spin dependent, charge independent. Now you have to see. Only spin and isospin dependent. Isospin is equal to 0. Option A is wrong. No spin, it is a spin dependent. Spin dependence but no tensor. Tensor means multi directions are there. There is existing. Spin is there means there is a multi dimension is there. Therefore, what is your option? Your option is spin dependence along with the tensor components. Option D is correct. Because if it is spinning means not only magnitudes, 1 by 2 magnitude is there, the spin quantum number, as well as orientations also is there. How many orientation we too don't know. Along with that, many types of orientations also is existing. That's why what is your answer? Spin dependence along with the tensor component. This one is nuclear forces question. When they are asking GATE 2012, that time this question was there. Now you have to see the basic process underlining the neutron beta decay. Beta decays are three varieties of beta decays are there. Suppose you have to take a beta decay. How many varieties are there? Three varieties are there. One is beta plus decay. This one is a positron decay. Next one is a beta minus decay. This decay is a electron decay. Next, third one is electron capture. Electron capture. Suppose you have to see here beta positive decay. Beta positive positron decay. How we have to write? There is a parent element XZA. Parent element XZA. Daughter. This is the daughter. Which one it is coming? Positron is coming out. If it is a positron is coming out means Z minus 1 according to the stoichiometry we have to write it. So plus which one it is out Nana? We have to out it. It is neutrino. Electron neutrino is out. This is the beta minus decay. Once you have to see the beta minus decay, XZA tends to Y Z minus 1. Z plus 1 you have to take A plus electron negative charge plus anti-neutrino. Anti-neutrino it will come. Which one it will come? Anti-neutrino it will come. Whether it may be electron caption XZA plus electron you have to capture it. Which one you will get? You will get Z minus 1 A plus neutrino. You are getting the neutrino, you have to get it. But what they are asking, the basic process underlining the neutron beta decay. Neutron beta decay. Neutron is undergoing to the beta decay. How it will be? Once you have to check it. Neutron can change into the proton and giving the electron, there is a anti-neutrino. This is the, which decay it is? This decay we call it as a neutron decay. Neutron decay means which particle it is? This particle is a down particle. Which particle is down? Up and down is there. That up particle is a proton. Down particle is the neutron. This is the quark model baryon. No? So down particle. Proton is the, which one it is? Up particle plus minus 1 0 electron neutrino. Therefore, down particle you have to show as a D, up particle you have to show as a U, E minus 1 0 plus electron anti-neutrino. This is the neutron decay. Neutron decay, which one it is Nana? D minus, D tends to U plus electron plus anti-neutrino. Option A is correct. Because neutron beta decay, neutron is decaying the beta particle while giving the proton. Neutron can interchange as a proton, proton can interchange as a neutron. Neutron interchange, which particle it is? Neutron is a down particle, proton is a up particle. D indicates down, U indicates up particle. Option A is correct. According to your status, option A is correct. Clear? Now you have to see the fifth one. In a spontaneous alpha decay, uranium 90 to 232, uranium 90 to 232 at rest, the total energy is released in the reaction is Q. Then the energy carried by the alpha particle energy, how much they are asking? Alpha particle energy, how much they are asking. Now only I told whether it may be alpha decay means this is the parent ZA, in daughter from Z 2 particles it is removing, from mass 4 particles is removing, helium T comma 4, Q is there, right? So this Q is energy, this energy is consist of Ke of alpha particle, Ke of Y particle, daughter particle. What they are asking? Ke of alpha particle they are asking. What is the formula? One formula I will give. You have to remember Ke of alpha particle is equal to Q into A minus 4 is divided by A. This is the formula. A minus 4 is divided by, if you have to take the alpha particle kinetic energy, A minus 4 is divided by A. If you have to take a daughter particle kinetic energy, 4 by A you have to write it. Therefore, Ke alpha by Q into A is equal to how much? 232 minus 4 is divided by 232. 232 is equal to 228 is divided by 232. So you have to subtract. Which one you have to subtract? You divided this, how much it will come? 4 5 ja, 4 7 ja, 4 5 ja, so 4 5 ja 20, 4 8 ja 32. Therefore, how much you are getting? Ke of alpha is equal to Q into 57 is divided by 58 you are getting. Option A you have to get. How simple it is. Just you know the formula, the kinetic energy of the alpha particle is equal to Q into A minus 4 is divided by A. Then easily you have to get it the option answer also. Very simple. 5 marks. This is a 5 marks question. June 2017 CSIR people are asking. How simple it is once you have to see. This much of easy you won't get. From the nuclear physics question will come. It is very easy. Now we will see the second one. The ground state of lead, lead 82, this is 82, sorry, 82207. The ground state of lead 82207 nucleus has spin parity is equal to, they are asking the ground state and which one we have to take? You have to lead 82207. Two states are there. One is the ground state, spin and parity is equal to 1 by 2 minus. Then another state is first excited state. First excited state, spin and parity is equal to how much? 5 by 2 minus. Ground state is equal to 1 by 2 minus. First excited state is equal to 5 by 2 minus. This is very, very important. The electromagnetic radiation emitted when the nucleus makes a transition from first excited state to second excited state, so ground state, there is a electromagnetic transition takes place. Which type of electromagnetic transition they are asking? First you have to see, this is the negative parity. It is also negative parity. No parity changes. No parity change. Plus keep in your mind. No parity change. Here you have to see, in ground state total angular momentum spin is equal to 1 by 2 and first excited state total angular momentum nuclear spin is equal to 5 by 2. Therefore, delta I is equal to delta J is equal to, which one we have to write, Nana? 5 by 2 plus 1 by 2 comma 5 by 2 minus 1 by 2. 5 by 2 plus 1 by 2 is equal to how much? 3. 5 by 2 minus 1 by 2 is equal to how much? 2. Right? There is a transition is there. 2, 3 and 2. How we have to follow? Once you have to see. Whether it may be electrical field, one rule is there. Suppose EL type. EL type you have to take. One formula is there. What is that formula? Parity phi is equal to minus 1 to the power of L. Right? Similarly, if you have to take MEL type, magnetic transition, because it is a electromagnetic radiation, their electric transition is there and magnetic transition is there. MEL type, parity phi is equal to minus 1 to the power of which one? L plus 1. Your L plus 1 means J plus 1 or L plus 1, whatever it may be. Instead of L, angular momentum, whether it may be total angular momentum you have to take. What are the delta I or delta J is equal to, you have to take it as a J, you have to take, whether it may be you have to take the J, is equal to which one you are getting? 3 and 2 you have to get. If you want to change the transition, if you want to change the parity, which one we have to substitute here? If you have to substitute the 3, negative it will come. If you have to substitute the 2, positive it will come. You get the 2 here, phi is equal to minus 1 to the power of 2. Then you are getting the positive, no change of the parity, right? Parity as it easily we will get it. That's why we have to write this is E2 transition. Which transition it is? E2 transition. Now I am coming into this, phi is equal to, if it is a magnetic field, so J plus 1. Which one we have to substitute instead of J? Minus 1 to the power of 3 plus 1. J is equal to 3 you have to substitute. You will get minus 1 to the power of 4 is equal to positive parity we are getting. Parity won't change. That's why J is equal to how much? 3. Therefore, ML or MJ type, what is that? M3 type is there. Which type it is? M3 type. Do not alter the parity. Do not alter the parity. We have to follow two things. One is E2 transition and M3 transition. E2 and M3. Which one option? Option C is correct. E2, E3 is wrong. M2, E3 is wrong. M2, E3 wrong. So, which option is correct? E2, M3 is correct. Only simply you will get the 5 marks. 5 marks simply you will get in CSIR. This is a electromagnetic radiation. Electromagnetic radiation transition. Gamma Teller transition and Fermi transitions are there. From the Fermi and Gamma Teller transitions, EL and ML types are there. From that we have to calculate this one. Please concentrate on this. Now you have to see. This is the 7th one. The recently discovered Higgs boson at a large hadron collision. This is very, very important. In June 2014, a Big Bang theory was there. In those days, in June 2014 early and 2013 end days, in Russian and NASA people and in France people, they did the research. They did one experiment. That experiment is a Big Bang theory experiment. Maybe that experiment, somewhat it is success, somewhat it is failure also is there. In that Big Bang theory experiment, what equipments they are using? Large hadron collision. Large hadron collision they are using. Large hadron collision they are using. Which bosons? Higgs boson. Those are Peter's Higgs boson introduced that particle. That particle is a God's particle. From that particle, Peter also came to India. The boson is Indian scientist only, Satyendranath boson. Now they are asking what is the thing once you have to see. Peter's Higgs boson, what happened you have to take. The E gamma is equal to, which one it will happen? The recently discovered Higgs boson at the Large Hadron experiment, collision experiment, as decay mode into a photon. Photon is decayed, and which one? Z boson decay into photon is decayed into Z boson plus gamma photon. Higgs boson particle is decayed into photon and Z boson. If the rest masses of the Higgs and Z bosons are 125 giga electron volt whole square, 90 giga electron volt square. This is the Higgs boson. You have to take Higgs boson. Higgs boson particle is decayed into Z boson and gamma particle. The decaying Higgs particle is at rest. The energy of the photon is equal to how much they are asking. The energy of the photon is equal to how much they are asking. How we have to write the energy of the photon? The energy of the photon is equal to E gamma is equal to EH square minus EZ square is divided by 2EH. There is a formula is there. EH square Higgs boson square minus EZ square is divided by 2EH formula is there. In this formula you have to substitute E gamma is equal to EH square is equal to how much is there, Nana? 125 giga electron volt is divided by C square whole square. EZ square is equal to 90 giga electron volt is divided whole square is divided by 2 into 125 you have to take. You simplify this, you are getting how much answer you have to get? 30 giga electron volt you have to get. This is the E gamma. E gamma, how much answer you are getting, Nana? 30 giga electron volt you are getting. This is very, very important. Which formula you have to use? You have to use this formula. Higgs boson is decay into Z boson and gamma particle. Which experiment? Large Hadron Collision experiment. This question belongs to who? Which question? This is a particle accelerator and detectors. This question also belongs to the relativistic kinematics. Relativistic kinematics question. Now once again you have to see one more question we have to see. The range of nuclear force between two nucleons is due to the exchange pions is 1.4 Fermi. If masses of the pion is 140 mega electron volt per C square, then the mass of the rho meson is 770 mega electron volt C square. Then the range of the force of the rho meson. The range of the force of the rho meson. One formula I will give you. So you have to remember the formula. So what is that formula? Once you have to see. That formula is the range is equal to h cut c is divided by mc square. H cut c is equal to 197 mega electron volt into Fermi. 197 mega electron volt into Fermi. H cut c is equal to, now you have to substitute, range is equal to 197 mega electron volt Fermi is divided by, what is m? Range of the rho meson. Which one we have to take? Rho meson. You have to identify rho meson. You have to take the rho meson. Rho meson 197 mega electron volt Fermi is divided by 770 mega electron volt in by C square into C square. C square mega electron volt get cancelled. You have to divide it with by 197 is divided by 770. How much you have to get it? 0.25 Fermi you are getting. How much you are getting? 0.25. Option C is correct. This is fundamental forces question. 4 forces are there. One force is strong force, one force is weak force, one force is electromagnetic force, one more force is gravitational forces. Maybe whenever I will teach the fundamental forces, in that time I will teach nicely. You have to remember this formula. From this formula we have to calculate the range of the rho meson. Clear? The range of the rho meson we have to calculate. Now the 9th question. Once you have to see, the charm quark number is S. Assigned a charm quantum number C is equal to 1. How should we Gell-Mann-Nishijima formula for the electrical charge? Electrical charge, there is a formula is there. How simple it is. June 2015 they are asking the question. Direct formula they are asking. Gell-Mann-Nishijima formula. Gell-Mann-Nishijima formula. What is the formula? Gell-Mann-Nishijima formula. We have to calculate the charge of the elementary particle. How we have to calculate? I3, third component of isospin, 1/2 into baryon number plus charm plus So strange particle. This is the, to find out the strange of that particle. This is very, very important. Q is equal to I3 plus 1 by 2 B plus S plus C. What is your option? Your option D is correct. Direct formula. When they are asking June 2015, they are asking this question. This question is a very, very important question. So please concentrate on this question. Now the last one you have to see. A particle which is a composite state of 3 quarks. Composite state of 3 quarks means that quark structure. This is the quark structure. The quark structure is equal to UDS. How many particles can exist UDS structure? You have to see. There is a baryons are there. Baryon, two types of baryons are there. In that spin-off baryons are there. Spin-off baryons. What are the spin-off baryons? Once you have to see the spin-off baryons. Proton and neutron and lambda 0. Proton and neutron, lambda 0, summation plus, summation 0, summation minus, cascade 0, cascade minus. These particles are cascade minus. These particles are which particle? Spin-off baryons particle. Now you have to write a quark model. How we have to write the quark model? By using these particles, we will see how we have to write the quark model. First we have to take that particle, proton comma neutron, lambda 0, summation plus, summation 0, summation minus, cascade 0, cascade minus. Cascade 0, cascade minus are there. First we have to write, how we have to write the quark structure once you have to see. First you write the proton here, you write a neutron here. This one is you have to do like this. Next summation positive, summation 0, summation minus you have to write here. Cascade 0, cascade 0, next cascade minus you have to write here. Now you do like this, right? Now you have to write the structure. Here one more particle is there, that is the lambda 0 also. First how you have to write the structure once you have to see. You start from here, U, up, 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 up. Next you have to write this one, down, down, down. This one you have to write, it is a strange, strange, strange. Now you see the opposite side. What is the missing letter is there? That missing letter you have to add. Here S is missing. Now you have to see here. Which one is missing? Which one is missing, Nana? D is missing. Now you have to see here. Which one is missing? U is missing. This is the structure. What is the proton structure? UUD. What is the neutron structure? UDD. What is the summation minus structure? This one. This one is a combination of all three. UDS structure. What are the particles of UDS structure? UDS structure particle is UDS structure particles are UD lambda 0 and summation 0. Lambda 0, summation 0. These are the UDS structure particle. What they are asking once you have to see. What is the respective charge summation 0 and lambda 0 particle? What is the charge? Charge is equal to 0, right? What is the spin? Already we know spin of baryon. Of baryon is there. What is the strangeness? How we have to calculate the strangeness? S is equal to how much? Spin is equal to 0 and S is charge is equal to 0. Spin is equal to 1 by 2. Charge is 0. This is not correct. This is not correct. This one is you have to see. This one directly you have to take. But how we have to get the minus once you have to see. How we have to get the strangeness. How we have to calculate the strangeness once you have to see. There is a formula is there to calculate the strangeness. Q is equal to I3 plus B plus S by 2. I3 is equal, Q is the charge.
How much charge is there? Suppose you have to take lambda 0. How much charge is there? 0 charge. What is the third component of isospin? Third component of isospin is equal to Q minus Q bar. Charge is equal to 0. The average charge of that component also 0. That is 0 minus 0 is equal to 0. Baryon number is equal to 1. You have to take it as a baryon. That particle is still baryon. That's why you have to take it as a 1 plus S by 2. Therefore, you simplify it. 0 plus something is equal to 1 plus S by 2. Cross multiply. 0 is equal to 1 plus S. Therefore, S is equal to minus 1. This is the strangeness of a conjugate particle. The what particle? Whether it may be lambda 0, summation 0. These two particles also strange particles only. What is the strange? Minus 1. What is your option? Your option is option C is correct. Charge is equal to 0. Spin is equal to 1 by 2. Strangeness is equal to minus 1. This is very easy. Nuclear and particle physics is very easy. Whatever the questions, 3 questions are coming in your CSIR exam, those 3 questions also easy only they will ask. Don't hesitate. If you really likes my teaching, you have to purchase my app, CSIR and GATE app. This course will help you in future, whatever the physics courses, maybe JL examination, DL examination, maybe CSIR examination and just exam, CSIR examination and GATE examination, GATE, just TIF for TIF for TIF for examination, or you have to write any exam, any scientific approaching exams, other IIT, they are conducting central universities, they are conducting PhD entrance tests, you able to qualify based on this coaching, right? Please, if you really likes, you have to purchase my app and you have to listen. Otherwise, you have to listen in our YouTube videos also. I will upload, but not entire content. Only some important content I will upload in YouTube also for making the known purpose only. For making the known purpose only I will upload, not entire the portion, because this portion I introduced all the introductions. Now you get the idea how much tough is there, how much syllabus is there. That's why all year it will takes place. If you really likes, you have to take the course. That course will start from 1/18/01/2024 onwards. Live classes we have to start. Recorded class already we built it. Whatever the in YouTube is there, there is introduction classes. Those classes will available in app also. Freely you have to listen in app also. Free content is available. You have to download my app. That app is Quantum Online Academy app. From your Play Store, Google Play Store, you have to download the app. That symbol is this one. So fees is somewhat is high. Don't think like that. We are providing the good quality of content, good quality of teaching. So much of syllabus is there. Throughout the year we have to teach. If you are not interested like that, individual papers also I will keep after some time. If it is mathematical methods of physics completed, I will make it a mathematical methods of physics course. Only whatever the paper you are weak, that paper you have to purchase. That is also no problem. But if you want to really poor background, if you really need, then you have to negotiate with me. My consult numbers are 9908437460. My institute number is 6303263368. Thank you so much. Thank you for listening your patience. Next, we will meet with one more nice video. You continuously learn with physics. Thank you. Thank you so much.